man, that's like 5 hours of practice. I haven't even hit one shot yet. Oh, shucks. Oh, jeez, man. I'm gonna need some magic if I'm gonna do well in tryouts tomorrow.
They're playing basketball. We love that basketball. They're playing basketball. We love.
I heard you were looking for a little magic in your shot.
Magic Elijah Bird? Oh no. 18 seasons, 28 championships, 19 MVPs? Oh my gosh.
If you want to make the basketball team tomorrow, the magic is all in the physics.
Mark is standing at the free throw line and needs to run to the end line to pass the ball in 15 feet away. He has 8 seconds until the buzzer sounds and his team, the Pizza Pockets, lose the national title. However, Mark knows that if he can pass the ball to Shabazz, his teammate, with 4 seconds left, he can score and win. Does Mark pass the ball in time? It takes him 1 second to pass the ball once he gets to it. Mark's acceleration is 3 feet per second squared. Let's look at our knowns. Distance equals 15 feet, initial velocity equals 0 feet per second, and acceleration equals 3 feet per second squared. We are looking for time. Now let's look at the equations of motion we have. As you can see, we must use the second equation because that one has all of our knowns and the one unknown we are trying to find. Now that we have the correct equation, let's solve for t. First, let's bring the 1/2 over to become twice the distance equals acceleration times time squared. Dividing by acceleration and taking the square root of both sides to get the equation time equals the square root of twice the distance divided by acceleration. Now let's plug and chug. Distance is 15 feet and acceleration is 3 feet per second squared. So, time equals the square root of 30 over 3, or the square root of 10, which equals roughly 3.16 seconds. Adding 1 second to pass the ball to Shabazz, the total time is 4.16 seconds, leaving 3.84 seconds left. So Shabazz is not supposed to make the shot, but he got a good look and drained it because this is my scenario and he can.
Magic Elijah Bird, I can't do this. Can you show me how?
I'll show you how it's done.
Magic Elijah Bird gets fouled after making the basket, so he heads to the free throw line. Magic has taken thousands of free throws, so every one is identical. How fast does the ball move upon release, assuming Magic shoots at a 45-degree angle? First, we must split the equation into x and y parts. The equation for the x direction is range equals velocity times the cosine of theta times time. Since there is no acceleration in the x direction, solving for t, we get that time equals the range over velocity multiplied by the cosine of theta. In the y direction, the equation is y equals velocity multiplied by sine of theta multiplied by time minus 1/2 multiplied by gravity multiplied by time squared. Plugging in t for our range equation, we get the following equation. Since sine over cosine is tangent, and pushing that quantity to the other side and distributing the -1, we get the following. Solving for v, we get the equation v equals the square root of gravity multiplied by range squared all over 2 multiplied by the cosine squared of theta multiplied by range times tangent of theta minus y. Now plugging and chugging, with acceleration due to gravity equal to 32 feet per second squared, range equaling 15 feet, theta equaling 45 degrees, and y equaling 3 feet, we get that vi equals 17.32 feet per second.
Taking a shot, take angle into consideration, because the higher the ball is above the rim, the more circular the rim is from the ball's perspective. Ipso facto, you're going to get it in. Bang. Compared to this,
This is what Magic taught me. Wow, Magic. With all this basketball knowledge you taught me through physics, I feel like I can beat anybody.
It's time for your final test. One-on-one.
Challenge accepted.